Look around you, what do you see? A world of objects, of things. Some are simple, a stone, a chair, but many are not. They move, they think, they respond. Your phone buzzes with a message from across the planet. Your car adjusts its own speed on the highway. A drone soars, capturing distant landscapes, not just machines, a new kind of creation, a fusion of mind and matter. They are the children of Mechatronics, born from the marriage of the physical and the digital. A story beyond engineering, human ingenuity reaching for the stars. One gear, one circuit, one line of code, an untold epic of breathing new life into inventions. It begins with the machine. For millennia, we were masters of mechanics, levers, gears, pulleys, magnificent creations born of sweat and cleverness. Think of the intricate clockwork of the Antikythera mechanism, an ancient device that modeled the cosmos with stunning precision. It was a mechanical brain, a universe captured in bronze gears. These early machines were powerful, but they were also deaf and blind. They followed a script written in the language of physics, unable to deviate, unable to learn, unable to adapt. The first great leap happened when we tamed lightning. Electricity, once a terrifying spectacle of nature, became our servant. In the 19th and early 20th centuries, we began to weave this invisible force into our mechanical world. The first step was simple but profound, the switch. With the flick of a finger we could command a machine to start or stop. Then came the electric motor, a revolutionary device that transformed electrical energy into motion. This new partnership between mechanics and electricity gave birth to automation. The next revolution arrived with a whisper carried on a stream of ones and zeros. The invention of the transistor in the mid-20th century changed everything. These tiny electronic switches were smaller, faster, more reliable. This allowed us to build something truly new: the digital computer. At first they were room-sized behemoths, their brains, thousands of vacuum tubes, then transistors. They were used for complex calculations, for cracking codes, for charting the paths of celestial bodies. But their destiny was to be miniaturized, to be placed inside our machines, becoming the ghost in the machine. With the advent of the microprocessor in the 1970s, a CPU could fit on a single tiny chip of silicon. This was the moment Mechatronics truly came of age. Now we could give machines not just a simple nervous system, but a programmable brain. The logic was no longer hardwired in a maze of relays and switches. It was now soft-wired, written in the flexible, editable language of software. Consider the evolution of the automobile. Early cars were purely mechanical, gears and linkages. But with the microprocessor, the car became a computer on wheels. This computer monitors sensors for oxygen levels, engine temperature, speed, and then precisely adjusts the fuel injection, adjusts ignition timing. Fast forward to today, the 20th of September, 2025. We live in a world saturated with mechatronics. It's so deeply embedded in our lives that, honestly, we often don't even notice it. That smartphone in your pocket, it's a mechatronic marvel. The mechanical vibration motor that gives you haptic feedback, the tiny camera lens that moves to focus, the accelerometer that senses when you rotate the screen. All of these are mechanical systems guided by a powerful computer. Look at the modern marvel of robotics. Robotic arms that assemble our cars with tireless precision, autonomous rovers exploring the surface of Mars. A Mars rover like Perseverance is a masterpiece of this discipline. It has a strong mechanical body with wheels and a robotic arm to navigate the harsh Martian terrain and collect samples. Even our homes are becoming mechatronic ecosystems. The robotic vacuum cleaner that navigates around your furniture uses a suite of sensors, infrared, bump sensors, to build a map of the room. Its software then plots the most efficient cleaning path. Your smart thermostat learns your daily routine and adjusts the temperature automatically to save energy. The integration has become so smooth, so elegant that the lines between the mechanical, the electronic, and the computational have blurred completely. They are no longer separate fields but three facets of a single unified whole. This is the essence of modern mechatronics. So where does this journey lead us? We stand on the brink of another great leap, one fueled by the explosive growth of artificial intelligence. The mechatronic systems of the past and present largely follow their programming. They operate within the bounds of the code we write for them. The future of mechatronics lies in creating systems that can learn, adapt, create on their own. We are moving from mere automation to true autonomy. Machines that don't just follow instructions but can understand intent and context. Imagine self-driving cars that communicate with each other, optimizing traffic flow across a city, preventing jams. Think of surgical robots that analyze live medical images, identify diseased tissue with microscopic precision, and perform maneuvers steadier than any human. These systems will combine advanced mechanical actuators, vast arrays of sensors, and learning algorithms that improve with every procedure worldwide. Smart factories where autonomous robots reconfigure themselves to build different products on the fly, learning and optimizing without human intervention. In our homes, assistive robots could help the elderly, help people with disabilities understanding spoken commands, even anticipating needs. In exploration, swarms of tiny mechatronic drones could explore cave systems or the deep ocean, collaborating to map unknown frontiers and sharing their findings in real time. The story of Mechatronics is, in the end, our story. From the first lever that lifted a heavy stone to the intelligent systems that will one day venture to distant stars. The symphony of creation continues, its music growing ever more complex and beautiful. The universe of possibilities is vast, and with Mechatronics as our instrument, we have only just begun to play.